7-ish, 7:15, 7:05, whenever you feel like you have enough questions to ask to get those questions answered. If you're in class tomorrow, do not hesitate to ask me questions when you come into class. All right, so let's go over to the review worksheet. So this was the practice B worksheet from Friday. And Friday, we just continued working with the radical expressions and rational exponents, which really is the first half of this chapter. That's been the focus of the first half of this chapter. So looking at number 7, we're going to start with this one. There are 2 different ways that we could approach this problem. And most of you use the method that we talked about in class on Friday, which is rationalizing the denominator. So in the numerator, we have an 11, and then we're dividing that by the 4th root of 11. To rationalize the denominator, it means that I need to get rid of any radical that's in the denominator. If it's a square root, I just multiply it by a square root. But in this case, it's a 4th root. So we need to multiply this by something so that when we're done, we have the 4th root of 11 to the 4th. So I'm going to just write that over here. Our end result, I want to have the 4th root of 11 to the 4th. Because then my exponent and my radical cancel, and I just end up with an 11. So that's our goal. So Ella, what could I multiply this by so that we have in the denominator the 4th root of 11 to the 4th?
4th root of 11 to the 3rd.
Yeah, so there already is 11 to the 1st there. So we multiply it by 11 to the 3rd. Whatever you do to the bottom, I need to do the same thing to the top. So now my top says 11 and then the 4th root of 11 cubed. I think I need to make my marker smaller here. So Ella, in the denominator, what do we now have?
Just 11.
Yeah, just 11. So the denominator is now just 11. That's what happens when you rationalize the denominator. And then Ella, to simplify this, we would?
The 11s cancel.
Yeah, the 11s cancel. So we end up with the 4th root of 11 cubed. And if you looked at the answer key, it kept it as an exponent, so 11 to the 3/4. On the quiz tomorrow, in parentheses, I'll tell you how to keep your answer. So I'll either have it in parentheses rational exponent, or I'll have radical expression, so that you kind of know how should I keep my answer for like specific problems like this. So you could keep it like this. You could have also cubed 11. And then you could have left it as that number, whatever 11 cubed is. So that would have been your other option. Any questions on number 7? So 11 to the 3/4 or the 4th root of 11 cubed, and you could actually cube 11 and get that value. All right, so let's look at the next problem that was on the sheet, and that was number 24, which is a really good problem to go over. You will see something similar to number 24 tomorrow. Maybe not as crazy with the fractions in this problem, but definitely something similar to this. So we have the cube root of x to the 4th times the square root of x to the 5th. And then that's raised to the -2 as the exponent. So there are a couple of different ways that we can try and work through this problem. Jaden, what did you do first when you saw this problem?
I took -2 and I put it into the, looks like I put it into the cube root. And I don't know, I can't tell if I distributed it into every single exponent or not. I think I did, yeah.
Yeah, so what did it look like? Like, what do you have for your next step?
I have x to the -8/3 times x to the -10/1. And then I forgot, I did the 1, and for some reason I didn't put it into the 4, but.
Okay, you're good. Nope, that sounds good. So the cube root of x to the fourth is really x to the 4/3. And then the square root of x to the fifth is really x to the 5/2. So she's saying she's taking that negative exponent and distributing it to both of the exponents that are up here. So she ended up having, she said x to the negative 8/3. And then when we take 5/2 times -2, we end up with -10/2, or just -5. So that would be the first step to think about. Kind of distributing that -2 to the exponents. So think about what that cube root of x to the fourth looks like as an exponent. So change it to the exponent form. The next step, we have to kind of think, we are multiplying and we have negative exponents. So again, you could do two things. You could combine the exponents together first. That would be one option, and keep them negative. The other option would be to make these exponents positive. So I could take it into the denominator because both of them are negative, and make positive exponents. Or you could keep them as negative exponents, combine them together, and then move it last. It's up to you. So you have a couple of options. So now, when you're multiplying exponents together, we know that those exponents need to be added. So we have to take 8/3 and add it to 5. So when you're multiplying, you add the exponents together. Valerio, what would the common denominator be of 8/3 plus 5?
It would be 3, so you would make it 15/3.
Yeah, so we would have to make that 15/3. And then when you add them together, Valerio, what do you get?
23/3.
Excellent, 23/3. So the negative exponent distributes to both exponents in the parentheses. Those exponents can move to the denominator because they're both negative, and then you need to add them together, excuse me, by getting a common denominator. So that's 1 over x to the 23/3. And it's 1 over that because the exponent was negative. So that's why it's in the denominator of the fraction. Any questions on that one, 24?
I took 2 out, or I don't know. Oh, never mind.
You sure, Faith?
Yeah, I got it.
Okay, all right. All right, the last one I thought we would look at is number 23, or I'm sorry, 32, to flip my numbers there. And again, you'll have a problem similar to this as well. So with the variables included in it, trying to multiply the two expressions together. So if you look at number 32, we have x, or I'm sorry, the square root of x cubed times y to the fourth times z, and then the square root of xyz to the fourth. So when you're multiplying, remember they have to be the same type of radical. They have to have the same index. So they're both square roots here, so we're allowed to multiply them together. When you multiply them, remember you're really adding the exponents. So that has an exponent of 1, that has an exponent of 1. So if we multiply these together, adding the exponents, Brooke, what do you get underneath one radical if we're trying to combine these together?
X to the fourth, y to the fifth, z to the fifth.
Yeah. So then this is really a square root, which means there's a little 2 there. How would that simplify, Brooke?
It would be x squared, y squared, z squared, and then the square root of y and z.
Awesome. Nice job. So each one of those, remember, you're kind of thinking about individually. So you're taking the square root of x to the 4th, the square root of y to the 5th, the square root of z to the 5th. And there's a little 2 on there. It's implied when it's a square root. If it's not written, it's just the square root, that little 2. And then how many times does 2 go into 4? Well, it goes in 2 times evenly. And then 2 goes into 5 2 times. The remainder is what stays underneath. So that extra exponent stays underneath. Are there any other questions on this worksheet? Those were the ones that were on the daily homework form, but are there other questions that you wanted to talk about on the worksheet? Okay. All right, so we are going to head over to Google Classroom then, and we are going to grab the worksheet for today, which is a review worksheet for tomorrow's quiz. There we go. So it should have just posted. You might have to pull your screen down and refresh it, but it's the mid-chapter 6 review worksheet. So the first group of problems on here, once you pull this up, would be similar to the 4 different sections that we did before we really got into chapter 6. And that was with the multiplying, the adding, subtracting, and then the dividing radicals. So most of these are in radicals except for the last group of problems. I wanted to just remind you about number 9 because this is like a common thing that I'm seeing with number 9. So just looking at the problems, the first couple are just kind of simplifying those radicals. Number 5 has a fraction in, like that's a fraction. We got to rationalize the denominator. And then it looks like 6, 7, and 8 are kind of just simplifying using multiplication. But if you look at number 9, we have 2 over 3 minus root 7. We have to rationalize this denominator. How do you rationalize a fraction like this? So think about what you need to do to rationalize this type of fraction when there's an expression in the denominator. Malachi, what would you do?
Don't you multiply each side by 3 minus radical 7?
You are so close.
Oh.
It is 3 and radical 7,
Oh,
but
plus.
instead of a minus, what goes in the middle of there?
It's a plus sign.
It is a plus sign. There we go. So we need to multiply it by its opposite, and that's called the conjugate. So we're multiplying it by its conjugate, not just the radical 7, because there's other terms in the denominator. So we multiply by 3 plus the square root of 7. So again, you're not just doing a radical root 7. There's a quantity there. We have to get rid of both pieces of that quantity, so we end up with one number. Just make sure that you are actually multiplying everything together. So you're taking 2 times root 3. And then we're taking 2 times root 7. I'm sorry, 2 times 3 and 2 times root 7. So that ends up with 6 plus 2 root 7. And then in the denominator, again, make sure you're foiling here. You're multiplying all the terms together. So then we simplify. On the top, we have 6 plus 2 root 7. On the bottom, the goal is to get the radical to cancel. That's what rationalizing the denominator means. We should not have a radical in the denominator. So 3 root 7 and negative 3 root 7 cancel. And then Malachi, what is the square root of 49?
7.
Yeah, so in the denominator, 9 minus 7 leaves us with
2.
2. Can this simplify any further, Malachi?
Yeah, it's like the 6 can turn into a 3 and then 2 into 1.
Excellent, you got it. Perfect. So everything's divisible by 2. So these guys here make it a 3, and then these turn into a 1. If you want to keep the 1 there, you can. You don't have to. You could just leave it as 3 plus root 7. But make sure you're simplifying both of them, not just the one. So in a fraction, what you do to one thing, you have to do to everything, just like an equation. So fractions and equations are very similar. Any questions on number 9? All right, so just to show you what the back side of the page looks like, I want you to cross off these directions where it says to round. We're not going to be rounding. I don't even know why I have them included in there. Solve for X, show all work. They should be exact. You'll be asked to keep it exact tomorrow. So those guys need to be exact. The last group of problems here, you can see these are the expressions containing variables. It says assume all variables are positive, which is what we've been talking about. You can see some of them, like number 29 has fractions in there. So just remember when you're subtracting the fractions, you have to have a common denominator. Looking at number 25, this is similar to the one that we went over with the exponents. So that little exponent can distribute to both of them. You can also think of this as x to the 2/3 and x to the 4/3, and then take that -3 to both of them as well. But that exponent needs to distribute. So this is very similar to number 24 that we went over. So as I said, you have a quiz tomorrow. Kind of look over the review worksheet, take a quick glance at it, see if there's any questions that you want to ask right now. I am going to remain on. You have 20 minutes. I'm giving you half of the class because if you were in my classroom, I would be walking around and answering questions and looking over your shoulder and seeing how you're doing. We're all at home today. So this is the time given to you to practice these concepts to prepare for tomorrow's quiz. Tomorrow's quiz has 18 questions, so about half of what is on here. Time yourself. See how long it takes you to complete 18 questions. If you have questions tomorrow morning, join me at 7 o'clock or ask when you come into the classroom because you're in school. As you're working, if you want to pop back in Zoom, I will be here. I keep my Zoom on until 8:05. So feel free to join me back in Zoom. I will let you back in if you have questions, or you can remain on and kind of work through it and ask questions if you see any. But I would say take a quick glance right now and just look and see if there's any that you want to ask before you leave. Otherwise, have a fantastic day. Please go out and enjoy the snow. I don't know if we're going to have another snow like this that like you could actually play in and go sled riding in. I mean, it is